Sir,
Yes,
we
sir.
were in the Zoom meeting. We can go to classroom, sir. No issue. Yeah.
Yes, yes. So we will have a quiz first and then we'll continue with the session.
Okay, sir.
And I have given the instructions for the quiz. So please go through it.
It has been uploaded in the Google Classroom, sir. Yes. Yeah.
Yes, yes.
Sir, right now only 43 participants.
Maybe we can have a little later, sir, once all people join. Hello, sir.
Yes.
Now participants seems to be less. I think 44 students only log in so far. Maybe can we give some time to others to join?
See, it is expected that you will be logged in. All of you should be logged in at least 5 minutes before.
Yes, sir. Many people logged in, even now, half an hour
Hmm.
earlier also. Anyway, some people still late.
Exam link is not there, no?
Hello?
Hello?
Yes?
I'm not able to find the link.
No, link not yet shared. Instruction only shared, I think.
Okay.
Yes, I have not yet uploaded the quiz. Just instruction I have uploaded.
The quiz is only from scheduling and maintenance, sir. Last class, you took that class only, correct, sir?
Yes. Yeah. So whatever we discussed in the previous 2 sessions.
Thanks, sir.
Sir, there will be numerical question also.
Okay, I am assigning the quiz now. It's already 10:05.
Okay. Not yet received the link.
But then how many have joined? It's 66 now. Huh?
Sir, as of now, 66, sir.
Hmm. Okay, I have assigned the quiz
Okay, sir.
and also I am sharing it through the email also, so that I hope all of you have received the quiz now, and
Yes, sir.
I have
We
shared
received
it
them.
on Classroom as well as through email also.
Okay.
So time allotted is 20 minutes, and you have to submit after the time is over.
Yeah.
So Pranav, did you get the link now? I got this message. I can read the message now.
Yes, sir. Yes, sir.
And time limit already announced. It is 20 minutes and 10 minutes are over. Can all of you turn on your videos? During exam, it is expected that all of you should keep your videos Okay, 5 minutes more. Last minute.
Professor, I got an error while submitting. Sorry, unable to open the file at this time. Please check the address. Once I hit the submit button, it gave me an error.
What's that error?
It's like, sorry, unable to open the file at this time. Please check the address again. Page not found.
Yogesh,
Uh,
the same thing came to me as well. Once you close it and check the initial browser, no, it is asking us our IAM login again. So without that, we would have gone in over there in haste. So the same thing happened to me now.
Oh,
I think your internet got disconnected in between.
Okay, time over. Quickly submit the quiz in next 10 seconds.
oh, okay.
So already it's exceeded by 1 minute.
Oh, all the answers are cleared.
Only we have selected the clear selection.
No,
Nice.
it got.
Go
I
ahead.
logged in
I
after.
think I'm also facing the same issue.
Yeah,
Sorry,
again, we
unable
have
to
to
open
select
the
it.
file at this time.
Okay, sure. I also had the same issue. Then I had to relog in and select all answers once again.
Yeah.
Oh. Okay.
Okay, I'm doing the same thing now.
Quickly submit.
Okay.
See, once the accepting the responses is deactivated, whatever response that you submit, it won't be saved. Okay.
Yeah. I have
You have to stick.
submitted whatever I can. I have selected and I have submitted.
Sir, will we get a response like in previous quiz, not in this thing, not in this sub module, not in this topic. Another topic, we received a confirmation mail that we have submitted. Anything like that? Any notification or like that after submission?
See, after submission, you get, I think, message, your responses are saved or something like that. Or you have submitted the quiz.
Yes, yes. Yeah, that I have got. Other will. Yes, sir.
Okay, so I am deactivating the link now. If you have not yet submitted, then you may lose even whatever responses that you have marked correct. Okay, so I'm just posting those responses which are saved. You may check your name in that. But of course, since all these things happens automatically, okay, my job here is just to prepare the quiz and upload it. So what happens, why the response is not saved, all those reasons may be because of the internet connectivity or any other reason, which are not in our control. Okay. So since you are also the user of the Google services, you know it that if anything happens on the back end, we don't have any control on that. So if anything happens or if anything, we will have one makeup quiz, which will be before the end exam. Okay. So maybe you can attempt that quiz then, provided those who are not able to write the quiz. Okay, so I have posted the responses which are saved in Google. You may check your name in that.
Classroom, sir.
You posted in Google Classroom, sir?
Yes, yes, I posted it in Google Classroom.
Sir, may I ask what is the list about, sir?
This list is those responses which are saved.
Okay, sir. Got it. Thank you, sir.
Okay then, so I have deactivated the link and okay, now we'll continue with our session. So is there anyone who has attempted the test but not his name is in this list? That means his response is not saved. Yes, Mr. Yogesh, what is the issue?
Nothing, Professor. So I just send the screenshot for future reference. I don't know if because many of us faced.
No, so is your name was included in that list?
Yeah, I re-logged in. So all of the responses which I selected were cleared. Some of them I remarked again and I have submitted.
Okay, you have submitted it. Okay.
Yeah, yeah.
I hope the screen is visible.
Yes, sir. Yes, sir.
Okay, so in our previous session, we discussed about the maintenance aspect, and then we also discussed about the reliability, then the role of reliability in the maintenance. That means how the reliability of the system is related with the maintenance, and we also discuss the relationship that exists between the reliability and quality, and also we discussed about the role of maintenance planning in the different other operations related to the shop floor planning. That means it may be related with the production scheduling, or it may be related with the quality, and it may be related with the inventory. So we have discussed also that the maintenance, even though it's the responsibility of the maintenance department, but then the effect of maintenance is having on the production as well as on the quality as well as on the inventory planning as well. So there is need that there has to be a coordination between all these functions. Then it will result in a kind of a good results as far as or the productivity for any industry. So we also discussed about the different measures related to the reliability indexes, that is MTBF or MTTR, MTTF, all these measures which are related with the reliability index that we have also discussed. Okay, so availability is nothing but the time during which the machine is available to carry out the production. So if we consider the total time for the machine, and if there are periods during which there is some breakdown or the machine is not available for production, so that time we call it as a downtime. Okay, so availability is nothing but it is given as the total time minus the uptime divided by minus downtime upon total time. And this time during which the machine is available, that means whatever the operating time of the machine, is called the uptime of the machine. So it is nothing but uptime to the total time. Okay, so we can see that availability is nothing but it's the total time minus downtime upon the total time, or it is also expressed in terms of the MTBF, that is mean time between failure upon mean time between failure plus mean time to repair. So if we consider this, so here the failure has occurred. After that, the machine was under maintenance. So this will represent the MTTR. And then again the machine will start operating, and again the failure will occur. So this time is nothing but this, we call it as the mean time between the failures. Okay, so availability is one of the important measure as far as the maintenance is concerned, because the effectiveness of the maintenance will result in the kind of availability that will be achieved for the manufacturing equipment. So if during maintenance, if we are just carrying out minor repair or minor adjustment, so in that particular case, the machine will not be restored to a particular state which should give a higher availability. But if we are carrying out some major replacement of the components, in which the components which were worn out or which were degraded, if we replace those components with a new, that means the component will start, in maintenance terminology, we call it as good as new. So if the components are as good as new, in that particular case, the machine reliability will improve as well as the machine availability will also improve. So the kind of maintenance that is being done for a machine will result in the availability. So availability is also one of the performance measure related with the maintenance function. Similarly, the downtime or the uptime also, because depending on the maintenance, what will be the reliability of the machine, and based on that, how it will perform in the next or the future operation period, and based on that, how many failures will occur, how many times the machine will be under breakdown, that will decide how much time the machine will be under downtime or under the downtime state. So that particular time during which the machine is not performing its intended function, that we consider it to be a downtime. So that depends on the effectiveness of the maintenance. So downtime is also one of the important performance measure as far as the maintenance function is concerned. Okay, so let's look at this example, and based on that, we'll see that how we can evaluate the different measures that we have discussed up till now. That means the failure rate, then the MTBF and MTTR, and how we can evaluate the availability. So it's the example related to a weight grinder, and a manufacturer of the weight grinder, it tested its product to assess the various performance measure. Okay. The 50 weight grinders were tested for a running time of 1000 hours, and it was found that there were total 60 failures during the testing phase. So 50 weight grinders, that means these machines were tested for 1000 hours. So the total duration of the testing was 50,000 hours. And out of those 50,000 hours, 60 failures were observed. So in 50,000 hours, 60 failures were observed, and in total, 1,350 were lost on account of identifying the problem and restoring it back to the working condition. So after the failure has occurred, the time that is spent on identifying the failure, that we call fault identification, and based on the fault, the machine is repaired and it is restored back to its working condition. So based on this, now we will try to evaluate or estimate these performance measure, which is in terms of the failure rate, the MTBF or the MTTR, and the availability of the particular machine. Okay, so the first performance measure, that is the failure rate. So failure rate, if you remember, it is number of failures per unit of the total time. Okay, so the number of failures in this case is equal to 60, and total time of the testing is 50,000 hours. So the failure rate is 0.0012 per hour. So based on the testing, almost 0.0012 failures were occurred per hour. So that is what is the meaning of failure rate. Now MTBF, that is mean time between failures. If you remember, it is, if we denote the failure rate as lambda, so mean time between failure is nothing but it is the total time divided by the number of failures, and it is also given by the 1 by lambda also. Okay, so the MTBF of this particular weight grinder is 833.33 hours. So whenever the machine is in operating, so this is what is the, so here the failure has occurred, here the failure has occurred, and this time between the two failure events, we call it as the MTBF. So MTBF is 833.33 hours for this particular case, and MTTR is nothing but it's the repair time. So the total time that is spent on repair is 1350, and it is mentioned here that this time it includes the active maintenance time as well as the fault identification. So the point from where the fault has occurred, but based on that we have to identify the fault, and then based on that we have to carry out the repair. So that total time spent in this case, it is 1350. And
Sir,
so
sir, in the formula MTBF, total time divided by number of failures, here what is the meaning of total time? Total available time, or sir the total time including breakdown?
So these 1000 hours, each of this particular machine is tested for 1000 hours. So the total time of testing was 50,000, and during those 50,000, there were 60 failures. Okay. So that means out of this total time during which the testing was done, total failures were 60. So the mean time between the failures is how much? It is 833. So on an average, after 833 hours, the failure has occurred. Okay, so the mean time it represents the average time. So
Okay,
this
sir.
total time of the testing is how much? It is 50,000, and in those 50,000, there were 60 failures. So on an average, what you can say, after 833 hours, there was one failure, and that will represent the mean time between failures for that particular component.
Okay, understood, sir.
Actually, the doubt is it the available time or is it the total uptime of that particular available time?
Which one? 50,000 hours.
This total, yes, sir, 50,000 hours.
50,000 hours is the total time.
In that case, MTBF should have the formula total uptime, sir. Like total uptime in the sense, whatever 50 hours minus that 60 failures are there, no, sir?
Mm-hmm.
That we have to go, I think.
So 60 is the number, okay?
60 is the number, but with respect to the 60 breakdown, there will be some breakdown hours also, no, sir? So total available time minus breakdown hours divided by number of failures should be the MTBF formula, actually.
No, but then the time during which the failures occurred, and based on that, the repair is being carried out, that will be accounted separately in terms of the MTTR. Okay. So MTTR is included as a part of MTBF.
That is correct, sir. That is for the repair time divided by number of repairs.
You can see that whenever we consider failure, a mean time between failure means the point at which the failure has occurred and the point at which the next failure has occurred. So during that, whatever the fault it starts, then we have to identify the fault, we have to take the corrective action, and based on that, the machine is again restored to the initial state, and then again it starts its functioning till the next failure it occurs. Okay. So like this, there were 60 failure instances during that particular 50,000 hours of operation. And during those 50,000, then we are considering that what is the average time. Okay, so we are not given here the time between individual failures. We are being given here, or we know the total number of failures that has occurred here.
Sir, but the doubt is like when if the repairing time is high, like say machine operates for 1 hour and repair time is 2 hours, and in 3 hours, what will be my mean time between failure? It cannot be 1.5 hours, right? It is 1 hour. My machine is running only for 1 hour. So that is like our doubt. Like the machine is running only for 1 hour and we are taking 2 hours to repair. So we should not consider those 2 hours as a time between failures.
See, your machine is operating for 1 hour. After that, the failure has occurred. Okay, so at this point, the failure has occurred here. Okay, you have restored the machine after 3 hours, isn't it? And after that, again, the machine will start its operating.
Yeah.
So here it's your is 1 hour. This time you are considering it as 3 hours. After that, the machine is restored. Again, it will operate for some duration.
Again, it is considered, again, it is operating for 1 hour only.
Only 1 hour. And then the failure has occurred.
Yeah.
Okay, so you will consider this total time because MTBF is nothing but it's a time between the two failure events. Okay, and during the operational period,
my machine was operating only for 1 hour. Between two failures, my machine was operating only for 1 hour. So that is why we were thinking like it should be 1 hour only. That was our analogy.
This is your operating time wherein there is no failure here. Okay. If your machine is operating for 1 hour, see, when you say between failure, what do you mean by it? The time span between two failures.
Okay.
Isn't it? So this is first failure has occurred and this is second failure. So the time between the two failure events, so in that, whatever the fault has occurred, whatever the failure has occurred, you will rectify that failure, you will repair it, you will restore the machine. Again, your machine will start operating. After that, the next failure will occur. This time we are considering as the time between failure. And over the operational period, let's say over a period of 1 month, what will happen? You will have number of failure events, isn't it? So you are interested to know what is the average time between the failure or mean time between the failure. So whatever is the total duration for which the machine was operating. Okay, and during that duration, how many failures has occurred? And based on that, you will be interested in how many on an average the failure, the time between failure was existing. So that time we call it as a mean time between failure. Okay, if you are considering only the uptime, okay, so during uptime there is no failure. Are you getting it? Because uptime is nothing but what? The time during which the machine is in operating condition. There is no failure during that. And after the uptime, because so from here your machine will start operating. Let's say here the first failure has occurred. Okay, you will identify the failure. Then let's say during this particular time, this was under repair. Again, you will start operating the machine, and then the second failure will occur. Okay, so during uptime, there is no failure. So uptime is nothing but it's a failure-free operation during which the machine is available, machine is in operating condition.
Like generally the total available hours minus breakdown hours is uptime, right, sir?
Yes, yes.
So for MTBF, generally we consider only uptime, no, sir? Not complete available hours.
See, what do you mean? So forget about the M now here. What is TBF?
Time between failure.
Time between failure. So when you will say time between failure, that means you will have to consider 2 failure events.
From first failure to second failure.
Second failure. Okay. But unless you are restoring the machine, how the second failure will occur? Isn't it? So if you have got a failure here, and the next failure, when it will be observed. So unless you rectify the first failure, you bring the machine again back to its operating condition. Again, the machine will start its functioning, and unless the next failure will occur, that will be considered as the time between failure.
So time between failure is the running time, sir, na? The available time.
Which one?
Time between two failure.
Sir, for example, say if we have 24 hours and we are running about 3 shifts in a factory, and a machine is available for completely 24 hours. And my breakdown, say for example, it is for about 3 hours. So my uptime now will be 24 hours minus this 3 hours is 21 hours. So while calculating between failure, so should I have to consider the total uptime, or should I have to consider the total available time?
Total
available time, like 24 hours, whatever available hours is there for 3 shifts, that I have to consider, or the total uptime, like breakdown hours, what 3 hours I have taken, 24 minus 21, 3 hours is 21. So between failure, while calculating with respect to this formula, should I have to consider 21 hours or 24 hours?
You will consider the total time.
24 hours.
Okay, you will consider, because you are interested in, on an average, how many failures that has occurred between the total time, because during that particular duration,
8 minutes, sir. 8 minutes. 3 hours might have about 3 hours might have about 5 to 6 breakdowns. So all 6 breakdowns included, it might be 3 hours. I'm not talking only about one particular breakdown. There might be, different breakdowns.
Okay.
So since we are from maintenance, no, sir, what we are doing is generally we are considering only uptime for calculating MTBF. So that's just a bit of confusion actually. Since you are telling it as available hours, we are considering on as uptime actually.
No, when you say the time between failures, okay, over a period of time. So it is nothing but what? It is the average time. So over a period of time, whenever the failure will occur, you will have to restore the machine, okay, and you will bring back that machine again in an operating condition. Again, the machine will start its functioning. So over a period of time, whatever the operation period that you have considered, let's say you have operated the machine for the, let's say 1 month, okay, let's say considering the 8-hour shift. So if you are interested in knowing what is the mean time between failures of that particular machine, so over a period of machine, whatever the number of failures that have occurred, that will be considered for estimating the mean time between failures.
Time to repair.
So in that even whatever the intermediate failures that have occurred over a period of time, those failures will also be included in that. Okay, so we will be interested in knowing the MTBF based on, so here the failure will occur, the machine will be, so it's basically we consider it as a fault. Okay, the fault has started, after that it is identified, it is then rectified. So this is nothing but MTTR, and after that the machine will start operating condition, and again the second fault will occur. Okay, so over a period of time, based on the number of faults that have occurred or failures that have occurred, you will have to consider that time, and based on that you will find the what is the mean time between failures.
Okay, sir.
So you consider only uptime?
Yes, sir. For that reason, I'm saying.
Yes, no, let's say over a period of 1 month, you have
for example,
the machine.
So, for example, 3 shift into 25 days, if I have to take in a month, leaving behind this Sundays. So 25 days into, say, for example, I have 30 machines. 25 machines into 24 hours into 30 machines. So for 30 machines, we will have some breakdowns. Say for about 60 or 70 irritants we have. Including those 60 irritants, if you have, say, about 70 hours or 80 hours of breakdown, then total available hours minus that total downtime, that is uptime. While calculating our MTBF, we are taking it as total uptime divided by the total number of breakdowns.
But then in uptime, how you are accounting for the failures? Because that is what is the operating time of the machine. It's a failure-free operation. Isn't it?
Sir, actually, sir, till now we have read this uptime divided by number of failure while calculating the MTBF. So that is the confusion. Actually, I am also working in a maintenance department in Honda. So we calculated the same way, uptime divided by number of failure. Or actually in a SAP system, we have the same formula we have put into SAP system. So our all reports are made by this calculation only. So so now we are confusing some.
Since you are taking it as a total available hours, we are considering only total lifetime, sir, actually. So total hour in why? Because for between failures, since the machine has stopped for 3 hours, that 3 hours we are not supposed to consider, no, sir. So only that whatever available, like 24 hours minus 21 hours is there, that 21 hours we have to consider, I feel, sir, for between failure. Because all this from past like 8 years we are doing only this one, sir. Now
we are also following the same as explained, but in we don't get zero value or something else. So we add +1 in the denominator.
Okay, so but then okay, I will check the literature again because as far as I know, when we are saying the mean time between failures, whatever the total time, because over a period of time, the machines will be, we can say whatever the failure has occurred, the machines will be restored. And based on the restoring of the machines, again, the machine will start operating its function. So let's say over a period of time, whenever you are looking at how many times the failure has occurred, that will be based on the time that you have considered, and on an average, how many failures has occurred during that particular instances. So uptime, it will include only the failure-free operation of that particular machine. Okay, so I'll check this and then again get back. Okay.
Yes, sir. Let's move on.
Since, okay. Okay, so the MTTR, if you want to find it out, then it will be the total repair time that has been incurred during that particular operation period divided by the number of failures that have been occurred. And before that, we can find out the mean time. What is the mean time that is involved in repairing the machine? And based on this, now we can estimate the availability that will be the uptime divided by the total time, or it can be MTBF upon MTBF plus MTTR. So based on this, we can find out the availability. So all these are basically related with the effectiveness of the maintenance function, because to what extent the maintenance has been carried out, and based on that, how it will affect the failure events that will have an impact on the mean time between failures, or based on the maintenance effectiveness, what kind of fault it occurs, and based on that, what will be the severity of that particular failure, so that it will involve the kind of repair time that will be involved in that particular failure, or based on that, how to what extent the machine will be having an uptime, and based on that, we can find out, or we can get the availability of that particular machine.
Sir, sir, in aluminium die casting, when machine get breakdowns, the temperature of the die and aluminium, the metal temperature goes down. When machine is rectified after the failure, the maintenance person, it is okay from my side, the machine is okay from my side, but production says that machine is not okay from my side because temperature has not received yet. Then in this case, whose mean time to repair will be considered? If we see from the perspective of the production, the machine is not available, but the maintenance, from the maintenance side, the machine is available now. Then
see, in typical die casting operation, for the first piece to become 100% okay, which will meet the entire specification, okay, so that reheating of the die and attaining the required parameter which are related with the process aspect, okay. So I think in that particular case, till the time you have restored the machine, that will be included as that should be included as an MTTR. Because heating of the die, attaining the required temperature, and then it should meet the entire specification of that aluminum die cast component, it will be a part of the process. Okay. So that will not be a part of your role as a part of the maintenance is being carried out, because it's a part of the process. So even if the machine is not failed, if you stop the machine and if you start it again, okay, so the moment the machine is started, it will not give the 100% okay component, which will meet the entire quality specification for that particular component. Okay. So in any die cast components, to achieve that required temperature, okay, it takes time. So in die casting, that is called, I think, the first piece. Okay, yes, so sir, the first piece, which is 100% correct, from that then they start the production.
Yes, sir.
So it will not be a part of MTTR.
Sir, one conflict is always there in whenever we talk about this die casting machine, because the production guy always say that my temperature goes down because maintenance has taken more time to repair the machine. So this is the reason why this downtime is happened. So they always say this downtime should be taken by the maintenance, but maintenance say we repaired our machine in stipulated time, and this is not our time. So
Okay,
this is
okay.
the confusion actually.
Yeah. So this is what is the conflicting situation. I think we have discussed in one of the session that there is always a conflict between maintenance and production people. Okay, nobody will try to take or own the responsibility, and always the blame goes on the other function. Even sometimes you may be having a conflict with the quality people also, because the production people, they will be looking for the number of pieces that they want to manufacture as a part of their production target. Okay, but then the first piece getting okay is a part of again the quality function. So it may happen that they may also put some blame on you that your work is not being so effective that we are not getting the first piece okay, and it is having so many rejections. So maybe many rejections they might be passing on your side.
Yes, sir.
But then it's a part of the process. So in any situation, typically in aluminum die casting, okay, the first part to become okay, even though the machine has not failed, it will take time. It's a part of the process.
Yes, sir.
It's a part of the process. So even if the machine is okay, even if the machine is new machine, you can ask the machine, the production person, that if you start and operate a new machine, will it give you the first piece as 100% correct or okay? It will never happen. Okay, it's a part of the process. So the die heating and achieving the required temperature so that all the specification can be met, it takes some time. So it's a part of the process, we can say.
One question related to same one. Hello?
Yes.
So in this case, my machine started to run and Gupta
your voice is cracking. Your voice is cracking.
So in case my production started and I started to produce a good part in for a few hours.
Still, it is not clear.
And I'm able to produce good part for 2 hours, and suddenly machine get breakdown in the 3rd hour. But maintenance get take only 1 hour, but to restore the temperature of the barrel temperature or what, but it should be linked to maintenance normally. But what is your guideline? Because the machine was running with the okay condition, hot startup has been done. When the machine is under breakdown, they will switch off the main, so all the temperature and others will get down. So to restore the temperature takes 45 minutes to 1 hour. That should be considered in the breakdown, or it is not a part of the breakdown. So my question is clear, sir.
No, the voice is not clear actually.
Okay, sir.
Can you speak little bit loud?
Sir, what I'm asking, my machine started to run for 2 hours with all okay conditions, and machine is getting breakdown on the 3rd hour. So my is taking another 1 hour to restore the part. So when he is taking 1 hour, all the machine temperature, pressure, everything goes down, and because the coolant is there, all the temperature will be down. And when he's giving okay, you can start the machine. In that case, I wait for another 1 hour to bring the machine back to the standard to make the validation whether the machine is okay or not okay. So in this case, 1 hour goes under the MTTR, or it should be considered in the startup loss.
Now it depends on, as I think the last question was also related to the same thing. Till the time, because see, from the production point of view, they will expect the machine to be in working condition, which will fulfill the requirement in terms of giving the correct product. That means which will meet the quality specification, which can be sent for or which can be delivered to the customer. Okay. So till that point, the production people, they will say that the machine is not working properly. So maybe in that case, then you may have to include it as a part of, because whatever restoration that you have done, unless that restoration is resulting in the workable condition of the machine, which will give the required output, which can be accepted by the quality. So those whatever trials that you are doing, because after rectification of the fault, you will have to do some kind of a trial, isn't it? To bring that machine in a workable condition, which will produce the output, which will produce the product, which is accepted by the quality and which can be delivered to the customer. So till that time, I think you will have to include it as a part of the MTTR then. So
okay, sir. Thank you.
Okay, from the production point of view, they will require the workable condition of the machine by which they will produce it, but then it should be accepted by the quality people.
Okay, sir. Thank you.
Okay, so we can see that the effect of the different maintenance alternatives that we have seen. So there are different maintenance alternatives. We can start with the routine inspection, wherein we can just inspect the machine and do some kind of a cleaning or greasing and lubrication. So you can see that the impact it increases in this particular in this direction, wherein the cost is also increasing. So the routine inspection, then the next level will be the preventive maintenance, which will have some more impact than the routine inspection, but of course it will involve some cost. Then the predictive maintenance, wherein you will have some more maintenance in terms of the kind of the condition monitoring, and based on that you may have to do some kind of the condition parameter, and based on the observation of the condition of the machine, based on certain parameters, it may be some kind of a noise, it may be some kind of a temperature or vibration, and based on that, but of course it will involve a lot of sensors being involved in that. So definitely you will be able to predict the condition of the machine, and maybe based on that you can take some corrective action. So of course that will also increase in terms of this. The next level it will be the breakdown maintenance. So here we are considering that based on the breakdown maintenance, we are doing some major even replacement of the component. So in this particular major breakdown, we are not looking at the repair. Okay, we are looking at replacing the component, so that the machine is getting there are many components which will be new components in that particular machine, and based on that it will give the required performance. Okay, so in that particular case it will result in, so we can say here that replacement of the components is occurring during that particular breakdown, and based on that we will improve the condition of the machine, so that it will have the more cost in terms of the replacement of the component. Then if you are doing the major overhaul of the machine, so definitely in that case many components will be replaced, and based on that the component will become, so more and more new components will be involved in that particular machine. So it will have a substantial impact on the performance of the machine, and maybe based on that you will get a good availability, but of course that will have the cost of maintenance, or that will increase the cost of maintenance. And finally we can say that if we are replacing the equipment, then definitely, because over a period of time we can see that the cost of maintenance it increases, whereas if you look at the depreciation, considering the depreciation, if you look at the salvage value of that particular machine, it goes on decreasing. Okay, so over a period of time you will see that the operation and maintenance cost it increases, whereas the value of that particular machine it decreases. So we have to come up with some trade-off point at which the decision will be in terms of whether we should continue the operation with that particular machine. But in that case, it will increase more operation and maintenance cost, or to replace the machine with the new one. So if you are entirely replacing the machine, so that will have a major impact in terms of the performance and productivity as far as the organization is concerned. So you can see that with this particular level of maintenance, if you go on increasing the level of maintenance, your cost will increase, but then you will get a good amount of productivity in terms of the availability of the machine, and maybe based on it will result in improvement in the productivity. Okay, so this bar-top curve we have already discussed. So if you look at the downtime, or if we consider the downtime analysis, so any downtime will not just involve the active downtime, it should also include the other downtime that is associated. Okay, so many times we consider the MTTR to be only the active downtime during which the machine is under maintenance. That means the machine is dismantled and some kind of maintenance is being performed, and based on that maintenance, the machine is restored to the workable condition. But then it should also include, apart from the active downtime or the active maintenance time, we should also include the administrative delay time as well as the logistic delay time. So administrative delay time will include the point at which the fault has occurred, reporting to the maintenance function, then the observation by the maintenance people, and based on that, whatever the fault that has been occurred, that has been confirmed, based on confirmation of the fault, whatever the spare requirement or whatever the other logistic support that is required, so that will also be included as a part of downtime. And after that, once the machine is dismantled, the entire maintenance has been done, so that will be included as a part of the active maintenance time. So in any maintenance, whether it's a corrective maintenance or a preventive maintenance or any condition-based maintenance, it will start with the fault identification and location. That means what kind of fault it has occurred, then where the fault has occurred, and based on that, the other administrative and logistic support that is needed. And based on that, then it will include the actual maintenance that we call it as the active maintenance time. So it will repair with the preparation of the machine for disassembly, then carrying out whatever the repair or replacement of that particular component, then again reassemble the machine if any alignment, calibration, that. So all these activities that will be included as a part of your active maintenance time, and that should be included as a part of MTTR. So whatever you have asked, it will be a part of this particular phase of the active maintenance time that is related with the verification. So based on whatever fault has occurred, you have done the corrective action, but whether that corrective action is resulting in the workable condition or not, so that you have to verify, and based on that only you can hand over that machine to the production people so that they can operate the machine and fulfill their objective of carrying out the production, meeting the quality specification. So till the verification and checkout, means it is being given or it is handed over to the production people, that will be included as a part of active maintenance time, which you may include it as a part of even MTTR as well. Okay, so it may be a preventive maintenance or it may be a condition-based maintenance. So you can see that any downtime when we consider, that means the mean time between failure that we consider, it include these particular total times that we are considering. So the MTBF, it includes the mean downtime and the mean uptime. Okay, so at this point the fault starts, and at this point again the next level of the fault it starts. Okay, so the time between these two is nothing but it's an MTBF. So the mean uptime, when we say, it includes the mean operating time, okay, and mean idle time. Okay, so during that particular phase, for any setup, for any setup change, if the machine is idle, for any let's say non-availability of the material, or if anything it happens, so that will also be included as a part of your uptime. So the mean idle time and mean operating time will be a part of your mean uptime. And now in mean downtime, there will be two components. One will be the mean waiting time, okay, and the second time it will be mean time to maintain. Because after the fault has occurred, okay, immediately the maintenance people, they won't rush to the machine and they can start dismantling it. So there is some time that we call it as, maybe it may be related with the administrative time, or it may be related with the logistics support time, if any spare is required, whether that spare is available or not, whatever. So because if any spare is not available, and maybe to arrive that spare, if it is taking time, so that will be a part of mean waiting time. So unless all the resources are readily available, the actual maintenance will not start. Okay, so this particular time we consider it as the mean waiting time. And once all the resources which are required for the maintenance, they are available, then we'll start the actual maintenance, where you will start dismantling the machine or disassembling the machine, and whatever repair, replace that is required, then again reassembling it, doing some kind of alignment, calibration, whatever is required, verifying the machine, and based on that you are making it ready for the production, so that it will be in a workable condition, so that the product which will meet the quality specification and which will be acceptable to the customer, those will be produced. So that will be a part of mean time to maintenance. So it will include the mean time to repair, and it will include the mean preventive maintenance downtime even. So in between, if you are carrying, so this mean time to repair will include if any intermediate kind of a repair adjustment if is required, and then if any preventive maintenance is being done, that may be also included as a part of your mean time to maintenance. Okay, so this total downtime will have so many components. So you will have to look at that which component is increasing. That means it is causing more downtime, by which the performance is being affected, and maybe based on that you may take some corrective actions, so that you can look at all these. So you can see that when we say the uptime or the downtime, there are so many components which are included in those, which should be taken care, or which should be looked at, so that it will improve the performance of the maintenance, and maybe based on that you can improve the productivity related with the particular manufacturing operations or functions are concerned, or you may improve the performance, maybe related with the availability, maybe related with the uptime, downtime, or the other performance measure that are looked at in any manufacturing function. So the availability of the data that is required for doing the analysis is based on a kind of information system. Okay, so maintenance function should have an information system. That means whatever all these functions that will be involved as a part of the maintenance, and based on that, whatever the corrective actions or whatever the activities which are involved, there has to be some system which will record all this, so that you will have a kind of data that will be available, and maybe using that data we can further improve the performance of the maintenance function. So a good information system is required for the efficient operation of the maintenance function, because to arrive at the different parameters associated with the maintenance. Okay, for example, if you want to come up with a maintenance policy, whether it will be an age-based policy that we have discussed, whether it will be a periodic or the time-based maintenance policy, or whether it's the other policy which is in terms of the repair limit, or maybe in terms of the failure limit, or opportunistic maintenance or selective maintenance, whatever the maintenance policy that we want to adopt, we should have a kind of data that should be available. Okay, because if we want to go for an age-based maintenance policy, in that particular case, we should have the failure history of the particular machine, so that which component has a certain age after which it gets failed. So that kind of analysis we are able to do it. So maybe based on that, we can come up with either an age-based policy, or maybe we can come up with the failure limit policy in that particular case, or which component is taking time for repairing. So if over a period of time, the repair time of that particular component, if it exceeds, so in that particular case, we can take a call that instead of repairing it now, we can replace the component, and so that it will start a good performance. So all these decisions, they are based on the availability of the data for planning the maintenance and executing the maintenance. So the information system should collect all the information. So whatever the events that occurs in the maintenance department related with the maintenance function, you should have some kind of a system that should capture all the data, and it should record that data. So for example, it may be in terms of the breakdown record, at what time the breakdown has occurred, the kind of breakdown, which component was included in that. Okay, then what kind of diagnosis, that means what is your observation or analysis based on that particular failure, and then which component is being replaced, whether you have replaced the entire subassembly, whatever it is. Then the quantum of the preventive maintenance, at what point you have done the preventive maintenance, during that preventive maintenance, what kind of actions that you have been taken, any major repair that have been carried out, or any major overhauls that have been done. So all this information, if it is properly stored as a part of the record, so that will form a good data which can be utilized in future for planning the effective maintenance as far as the maintenance function is concerned. So the basic data, for example, the breakdown frequency, based on that, the probabilities of failures, you can find it out. The mean downtime, the mean repair time, the failure rates, you can calculate based on this. You can develop the troubleshooting mechanism. Even you can do some kind of an analysis, which we call it as the fault tree analysis, where we try to drill down to the basic event that we call it in terms of the fault tree analysis, that whenever the fault has occurred, we have to drill it down to what is the basic reason by which this particular fault has occurred. So that kind of fault tree analysis can be done. And of course, for developing the fault trees, you need the kind of information based on what kind of maintenance or previous actions that have been done. Of course, what is the cost of the maintenance? Then based on that, you may have certain decision in terms of the major overhauls, or maybe in terms of some kind of the replacement that we have discussed, because over a period of time, because of the continuous operation, and over a period of time, because of the degradation of the different components in the machine, the operation and maintenance cost, it will increase. And if we look at the value of the machine, that we call is in accounting term as the salvage value, because of the depreciation, it will keep on decreasing. So it should not have that you are operating in a machine which is having a very high value of the operation and maintenance cost. So instead of that, if you replace the machine with a new, that will result in a better productivity. So similarly, you can do some kind of a failure analysis, the breakdown frequency. So all these analysis will be possible based on the kind of data that is available. But unfortunately, in as far as the many Indian industries, specifically the small scale or medium scale, of course, large scale industries nowadays, they are quite aware of the importance of the failure data. But even today, we can see that many small scale and even medium scale industries, they are not trying to maintain the kind of data that is associated with the maintenance activities. And based on that, they are operating maybe many times with a very conventional way of operating the machine, which was like run till failure kind of a thing. Okay, so in that particular situation, the cost of the maintenance, it increases, because we have seen that over a period of time, because of the continuous running and continuous degradation of the component, the failure frequency will increase, and based on that your cost of maintenance will also increase. So if we are maintaining all the data related with the failure, related with the repair, related with the activities which are performed as a part of the maintenance function, if that database will serve as a good record for planning the future maintenance, coming up with maintenance policies, and based on that it will result in good availability, or it will also result in the achieving the required productivity for the particular organization. Yes, Neeraj?
Sir, I want to share one more policy. Practically, we have implemented in our company. Actually, 80-20 principle. If we analyze the all historical data of all the machines, we found that 80% of problems occurred due to 20% of the part of the machine. So we implemented one phenomena-based policy. For those 20% parts, we do the additional preventive maintenance so that we can reduce the overall downtime of the machine. So we have done this by analyzing all the historical data. So that I want to say.
Of course, of course. So that is true. So whatever you have said, 80-20 principle, that is called the Pareto's law.
Yes, sir.
Okay, so it's a Pareto principle, and not only it's applicable in the maintenance, it's applicable in many phenomena. So I'm going to discuss about that maybe. So that what you are talking is about the Pareto principle or the Pareto analysis, and it's applicable in many phenomena. Okay, so it started with the Pareto has given this principle. It's based on the fact that 80% of the wealth is occupied with 20% of the people, and this is true in many situations. Okay, even if you look at any organizational performance, so even though all the people they work, but then the excellence in that organization, so the 80% of the excellence is achieved by 20% of the contribution of that particular people. So even in machines also, if you look at if you do the failure analysis, you will find that 80% of the failures will be observed by, or will be occurred based on the 20%. So have you considered the reliability centered maintenance? Because what you are talking about is a part of RCM process.
Yes, sir.
Okay, so to some extent, it's a part of the RCM process, wherein you look at the improving the function based on doing the analysis in terms of, so Pareto analysis is one of the aspect related to the RCM, that is called the reliability centered maintenance approach, wherein you focus on the functions of the particular component, and based on that you do the analysis so that the reliability of that particular machine has to be improved.
Yes.
Okay. Okay, so we'll take a break. It's 11:30, and after that we will resume the session, and we will look at the waiting line principle, because in machine maintenance, whatever the machines they will be undergoing the maintenance, and a long queue is being formed. So maybe based on that, how much time the machine will spend, and based on that, you can plan for the resources, so that you can do a planning for your maintenance function, as well as you can plan for the resources. So we will look at this aspect, that how the waiting line concept can be applicable in case of the machine maintenance, and we will discuss it after the break is over. Okay, yeah, thank you. because in any maintenance or for any maintenance department, there will be a queue of the machines which will be arriving for the maintenance. So depending on the different times that we call it in terms of the mean time between failures or in terms of the mean time to repair, how we can analyze the maintenance function in terms of the waiting line that gets created. Okay, so this is typically any waiting line it operates, which we call it as a single channel waiting line. So here there will be a number of customers who will be arriving. So for a maintenance, the number of customers is nothing but the machines that will be arriving, and those machines will be available for maintenance. So this we consider as the maintenance department, wherein there will be, so the service facility is nothing but the maintenance department, wherein there will be number of service facilities available. It may be in terms of the maintenance people who will be available for the maintenance or the maintenance team. So depending on the organization structure of that particular maintenance department, you will have the number of service facilities that will be available. So the machines will be arrived at the maintenance function. So the machines, based on their failures, that will form a queue, and based on the service that is being given by the maintenance department in terms of the maintenance that is carried out, the machines in workable condition then will come out of this particular queuing system. So we can analyze the situation of the number of machines which are waiting for the service in case of the maintenance function as a part of the waiting line or queuing line theory. And based on that, we can decide that how many machines they are waiting and what will be the time that will be spent by the machine maybe in the system. So all these we can evaluate. So for any waiting line, there will be 3 elements which will be involved as a part of the queuing system. The first will be the customer who will be arriving at the service facility. That means here the maintenance function. There will be a queue formation, because based on the arrival of the customers, the queue will be formed, and there will be a service channel, which is nothing but the maintenance function. So depending on these 3 elements, we can analyze the maintenance as a queuing model. So queuing theory, which is quite popular in the operation research, we can apply this queuing theory, or we can model this maintenance function as a part of the queuing model. And based on that, we can decide that what will be the length of the queue that will be formed for a maintenance department, how much time the machine will be spending in the queue, or how much time the machine will spend in the system. So that analysis can be done. So for any queuing model, there are different elements which are involved. The first element is the inter-arrival time that we call. That means it is the input or the arrival distribution, which we call it as the inter-arrival time. So in case of any service facility, the customers will be arriving after a stipulated time. Okay, so that we consider it as an inter-arrival time. For example, if you go to any bank or even in the maintenance department, after a certain period of time, based on the failure of those machines, the machines will be arriving for the maintenance, and that can be a part of the inter-arrival time. The departure or the service distribution. Okay, so the arrival distribution is generally considered to be a Poisson process, and the distribution is considered as the Poisson distribution. The departure is considered to be the exponential distribution. That means how much time that is being given to serve that particular customer. So to rectify or restore that machine, that will be a part of the service distribution for the maintenance. Then the service channel, whether it is a single or whether it is a multiple. Then the service discipline, the maximum number of customers allowed in the system, whether it's finite or infinite. For example, if we consider the maintenance function, out of the limited number of machines which will be in the organization, so those machines will be arriving for the maintenance. So in that case, we can consider it to be a finite population. In queuing theory or in waiting line, there is infinite number of customers that may be allowed. For example, if you consider any bank or any reservation system that occurs at any railway station or even to any dispensary where the doctor is giving the service. So in that particular case, the number of customers that will be arriving at the service facility will be from the infinite. So the maximum number of customers that will be allowed, that will be based on, and then the calling source or the population. So from where the customers they are coming. So again, it will have a finite or infinite. Okay. So from which population the customers are coming. So in case of a maintenance, whatever the number of machines that are available in that particular organization, those will be coming for the maintenance. So whatever is the population that we are considering here will be the number of machines in the company. So in that case, it will become the finite population. But in other situation where the number of customers will be coming from an open population, in that case, we consider it as an infinite population. So depending on the combinations of all these parameters, there are different models that exist for the waiting line, and based on that, we can have different models or formulation of the waiting line. We will consider this particular single channel system wherein we have a number of machines which will be arriving, and based on the number of facilities, the machines will be maintained, and maybe based on that, the machines will be restored, and then again they will send to the production function. So in that particular case, the lambda here is the arrival rate, and mu here is called the service rate. Okay, so this lambda is based on the Poisson distribution, and this mu is based on the exponential distribution. So based on the values of the lambda and the mu, that is the arrival rate. For example, in case of, let's say, the machine shop wherein the machines are operating, and based on that, if the machines are getting into the maintenance department. So on an average, we can say that the arrival rate is, let's say after every 1 week, or let's say after every 10 days, one machine is arriving for the maintenance. Okay. So, but then it's called the average time during which, or we can call it as the mean arrival rate of that particular service channel is concerned. Similarly, the mean service rate, that means how much time it is taking to provide the service. That means how much time is being taken on an average to provide the service. So that is being considered as a part of the service rate, which we call it as the mean service rate, or this we call it as the mean arrival rate. So this utilization factor is nothing but lambda upon mu. So that means arrival rate divided by the service rate. Okay. So if this utilization factor is less than 1, and if it is greater than 1. Okay. So what will happen? So ideally it is expected that this utilization factor should be less than 1, because your arrival rate should be less as compared to your service rate. Otherwise, if your arrival rate is more and if your service rate is low, in that case, what will happen? This utilization factor will become greater than 1. So what will be the impact of that? It will result in
queue size
indefinite formation of the queue. Okay. So the queue will become endless. So you have to ensure that the utilization factor should be less than 1. Okay. In that case only, it will form, or it will result in the less number of customers in that particular queue. Otherwise, if it is greater than 1, then it will result into an endless queue. So of course, based on that, you'll have to take measures by which you can increase the service rate. So maybe you can create few parallel facilities by which you can to improve this utilization factor, and you can bring it back to less than 1, so that it will become a finite queue length. Otherwise, it will become an infinite queue length in that particular case. So based on the mathematical analysis, the length of the queue that is formed will be given using based on what is the arrival rate and what is the service rate. So the length of the queue will be given so this is formed, this will be the queue. And this will be the system. So the queue will include the number of customers. That means in this case, the number of machines which are waiting for the maintenance, and the system will include the queue as well as whatever the machine is under maintenance. So that will be considered as the part of the system. So the length of the queue will be given by this particular model. Length of the system, that means how many machines will be in the queue, and along with that, how many machines will be under maintenance. So that will be a part of the length of the system. Then waiting time in the queue, that means how much time that that will be required. That means how much time will be the waiting time in this particular duration that will be in the queue. And then waiting time in the system, that will include waiting time in the queue as well as waiting time in the system. That means during which the service is being given to that particular customer. So in case of the maintenance, it will be the machine which is under maintenance, and at the same time, the machines which are waiting for their maintenance due. So that will form the waiting time for the machine in the system. So in any queuing line, we are mainly concerned with these 4 important parameters or 4 important measures. That is length of the queue, length of the system, waiting time in the queue, and waiting time in the system. And of course, what is the utilization factor for that particular service channel or service system. And of course, we have to ensure that the utilization factor to be less than 1. Otherwise, it may result in an infinite queue length. Okay. So let's consider this example, and based on that, we'll see how we can estimate these different elements related to the maintenance function, applying the queuing line or waiting line theory. So a machine shop has several multi-purpose machine tools, okay, and the arrival rate is 1 every 80 hours. Okay, so this is what is the arrival rate. So on an average, after every 18 hours, 1 machine is arrived for the maintenance. The MTTR is estimated to be 14 hours. Okay, and the MTTR, that means service rate, it will follow the negative exponential distribution, and the arrival, it follows the Poisson distribution process, because the arrival pattern is normally a part of the Poisson process. Okay, because there will be, we can say, intermittent arrival of the number of facilities or the number of customers in any service channel. For example, 1 machine may arrive in 10 hours, 2nd machine may arrive 20 hours, 3rd machine may arrive next, say, 15 hours. So on an average, then we say that on an average, the arrival rate is 1 machine every 18 hours. That we consider it as the arrival rate based on the Poisson process. And similarly, the service rate is considered to be the time between the two service, the time between the service which is being given to those particular customers. So that's a part of continuous time. So we consider it as a part of the negative the exponential distribution, and it's called the negative exponential distribution. And whatever the downtime that is associated, that downtime is having some cost consequence, okay? Because whenever the machine is under breakdown state or wherever the machine is down, it doesn't affect only the direct, or it will not just involve the direct cost, it will also involve the indirect cost also. So whatever the time the machine is under breakdown or the machine is under down state, there will be a consequence in terms of not producing, and that means you are losing the productivity out of the downtime of that particular machine or that particular failed machine. So that we consider it as the consequence of the failure. So the consequence of failure, it will result in the maintenance cost, which we consider it as a direct cost, but it will have a kind of indirect cost in terms of the cost of the lost productivity, or we call it as cost of lost opportunity also. So that is almost related to, here it is given, which is 22,500 per hour. Okay, so based on that, we can find out the number of machines in the machine shop waiting or undergoing the repair. Then what is the turnaround time for the failed machines, and what is the productivity loss? That means whatever the time the machines are under breakdown, due to that, how much loss will incur in terms of the productivity. So we can utilize the waiting line or the queuing theory principles, and based on that, we can find it out. So in this case, the arrival rate will be equal to 1 upon 18. So how much this gets? So it is 0.056. The service rate is mu, that is 1 by 14, that is 0.071. And the utilization is now based on that lambda upon mu. So you can see that it is 0.7887, which is less than 1. That means it will result in a finite queue length. Okay, so we have to ensure that whatever the arrival rate and whatever the service rate, it should result in a finite queue length. Otherwise, if this gets greater than 1, then it results in an infinite queue length. Okay, so the number of machines which are waiting for repair, that means what? The length of the queue. So the length of the queue will be given by this particular model, that is lambda square upon mu into mu minus lambda. So that means there are 2.94 machines which are waiting for repair. So this is nothing but this is the queue length. The number of machines in the system, that means the machines which are in the waiting as well as the machine which will be in the system, that will be equal to length of the queue plus the utilization factor. So it will be 3.73 in this case. So this will include the machines in the queue as well as the machine which is waiting or which is under maintenance in the maintenance department. And the turnaround time is nothing but the waiting time for the machine in the system. Okay, so the waiting time for the machine in the system, it is given by LS, that is length of the system divided by the lambda. So that means on an average 66.61 hours will be waiting for this particular machine. So it will include the machines which are in queue as well as the machine which is in the system. That means the machine which is undergoing the maintenance as well. So the turnaround time will be 66.61 hours, and we can, based on that, we can estimate the productivity loss, because per hour productivity loss is 22,500. So based on that, we can evaluate that the productivity loss is almost 14,98,000. So that based on these estimates, we can look at the performance of the maintenance function, maybe in terms of either improving the maintenance so that the arrival rate will change, or we can improve the service rate so that we can have a less turnaround time, so that it will result in the less productivity loss as far as the particular maintenance function is concerned. So the point here is that this waiting line theory, or the concept of the queuing theory, can be applied to the maintenance function, and based on that, we can improve the performance of the maintenance. That will result in improving the productivity also. Okay. Is this clear, or if any doubt, really, you can ask. Okay, so that was about the maintenance and the using the queuing theory or waiting line theory, so that the maintenance performance can be improved in terms of improving the maintenance effectiveness itself, so that will result in less failure, so that the arrival rate will change, or improving the service in terms of arranging the resources so that the service rate can be improved, so that it will result in reducing the number of machines which are waiting for the maintenance, or the turnaround time for the machines, so that it will result in less productivity loss for the machines which are involved. Okay, so now we will look at one of the important aspect related to maintenance, and which is very popular in many industrial organizations, that is the total productive maintenance. Okay, so it involves the three aspects, that is total, productive, and maintenance. So TPM is a term which is quite popular in many industries, and it has some kind of a resemblance to the total quality management, which is involvement of the people, or the involvement of all the people in the organization in the quality achievement. Similarly, as a part of the involvement of the people in achieving the maintenance that will improve the productivity, because we have seen that whatever the downtime it results, there are so many aspects associated with the downtime. It's not that just the downtime is on account of the maintenance people only, it is on account of the other functions which are also involved, because we have seen that downtime, it includes the part associated with the administration activities, the part associated with the logistic support, and the other functions which are also involved in that. So from that point of view, if all the people who are associated with the upcoming, or we can say the maintaining of the machines in more productive way, so that being considered as a basis, and kind of an approach is developed, that is called the total productive maintenance. Okay, so we have seen that in many situations the maintenance function is considered to be the responsibility of the maintenance department only. Okay, but then the thinking has to be changed in terms of the involvement of all those who are concerned with the machines. It may be the maintenance people, it may be even the operators, it may be maybe the production people who are handling those machines. So total productive maintenance will look into this aspect, and based on that, the objective is to achieve zero breakdowns, to achieve zero accidents, to achieve zero losses, and to achieve zero defects. So the effectiveness of the maintenance is improved to such a level, so that it will involve all these aspects in terms of the zero breakdown, in terms of the zero accident, in terms of zero losses, that will have an effect on the performance, and to achieve the zero defects even. So TPM is nothing but it's the process of using the machine, equipment, employees, and all the supporting process to maintain and improve the integrity of the production and the quality of the system. Okay, because we have seen during our discussions that even though maintenance is a function for which the maintenance department is responsible, but then in the operational context, maintenance has connection with the production, maintenance has a connection with the inventories, maintenance has a connection with the quality. And of course, if all these functions, they are disrupted, that will have a disruption effect on the other functions in the organization. So from that point of view, it's not just the responsibility of the maintenance people only to keep the machines in good working conditions, but it should become a kind of environment wherein all the people who are connected with the operation of the machine, they should be involved so that the machines will be in good conditions that may achieve in terms of all these four important factors, that is zero breakdown or zero accidents or zero losses or even the zero defect. Okay, so definitely it will result in improving the productivity, and as well as it will result in improving the competitiveness of the manufacturing. Okay, so this total productive maintenance is based on the 8 pillars. Okay, so there are 8 pillars of the TPM which are identified in any manufacturing organization. These pillars are, so the foundation, at the foundation of these particular 8 pillars is the 5S concept. Okay, so the 8 pillars are autonomous maintenance, then planned maintenance, quality maintenance, focused improvement, early equipment management, then training and education, safety, health and environment, as well as in administration also. But of course, the foundation is based on the 5S principle. Okay, so many of you may be knowing these 5S concepts. So 5S is a Japanese concept which looks at improving the work environment. Okay, so whenever we have a work environment, we should keep it in a good or organized way so that we can apply these 5S that are considered. So the first S is considered to be the sort. So all these are the Japanese term. So the 5S in terms of Japanese, they are identified as Siri, Siton, Siso, Siketsu, and Sitsuke. So the English meaning is sorting, setting in order, shine, standardize, and sustain. So whenever we are looking at any working environment, we should apply the 5S, and based on that, the work environment, if it is improved, that will result in improving the productivity. So the first S is set is that sort. Okay, so whatever equipment, material that are lying in your work environment, you have to sort the items. That means which are useful and which are not useful, because in any work environment we can see that it always happens in a very disorganized way or unorganized way. So the first principle of the 5S is related with the sort activity. That means whatever is useful and whatever is not useful or unwanted things, so that you have to sort those items. And then the second S you have to apply based on the first. So once you have sorted it, the second S is set in order. So depending on the work environment, whatever the process that is being followed, looking at that particular, we can organize or set the items or set the equipments. Let's say if it is a kind of the manufacturing workstation. So whatever toolings and all those they are required, if they are sorted, that which are useful and which are not useful. And based on that, depending on the requirement, we have to set all these equipments in proper order. And then the third set, the third S is called the shine, wherein we can make some kind of a marking related to it, so that some kind of a visual displays, some kind of the we can say visuals we can create, so that the equipments are easily identifiable. Okay, so that is related with the shine aspect of the, or that we consider it as the third S. and then we have to standardize the system. Okay, so based on the first three, that is sort, set in order, and shine, we have to standardize the system, and then at the last S we consider is to sustain. So whatever improvements that we have done as a part of the first four, we have to sustain those, so that again it should not happen that we have organized the thing, we have standardized the thing, but again when the next level or next cycle of operation is start, again we keep the things in a very unorganized way. So that kind of sustainable attitude that we should have, so that whatever improvements that we have done based on the earlier four, we should sustain with those particular 4S, so that it should become a continuous process. It should become a part of continuous improvement. So in any total productive maintenance, the first step is the 5S, so that we have to first organize the work environment, and now with that organized work environment, we can apply the different pillars which are created for this particular total productive maintenance. Okay, so the first pillar of the TPM is the autonomous maintenance. So autonomous maintenance is that the operators, they will be doing, or they should be trained so that they will do the routine maintenance like cleaning, lubricating, inspecting, as well as so the basic aspect, because when the operator is going to the machine, okay, that machine has to be cleaned, that machine has to be lubricated, that machine has to be inspected first. So all these will be a part of autonomous maintenance. So it should not become the responsibility of the maintenance people, that the maintenance people will clean the machine, the maintenance people should only lubricate it, they should only inspect it. The operator who is working on that machine, if we train that person in these activities, so before starting the machine, if he is doing these kind of routine inspection or routine maintenance activity, that will become a part of the autonomous maintenance. So the TPM is based on some human aspect, because if we try to give the ownership of the equipment, okay, to the operator, that will become a proud feeling for him, even because we can see that if we own something, we try to do it in a more better way. So in that sense, the autonomous maintenance will give a feeling of ownership of the equipment, and it will also increase their knowledge, okay, because the operator who are operating that particular machine, they are more aware of let's say the faults that are occurring in that particular machine. So if any early fault, if it is being observed, maybe based on the inspection of the machine, and if it is reported to the maintenance department, so if that fault is being rectified at its early stage, that will not result in a major breakdown maybe in future. So if we are doing the autonomous maintenance, whatever the early signs of failure are identified or observed by the operator, those, if they are reported to the maintenance department, that can be rectified at its early phase, so that we can avoid the major breakdowns in future. So the autonomous maintenance will try to ensure that machinery is always clean and lubricated, and it will help to identify the issues before they become the major failure. So the first pillar of TPM is the autonomous maintenance. That means fixing the responsibility of the routine inspection to the operator. The second pillar is about the focus improvement. So the as far as the Japanese concept is concerned, the continuous improvement is called the Kaizen. Okay, so as a part of the Kaizen activities, so that whatever the small improvements can be done, if those are being identified and if those are being implemented, that will improve the performance of the machine, and that will improve the performance of the system. Okay, so based on the brainstorming of the operator, based on the smaller teams who are proactively working together for improving and for increasing the improvements in the work environment, so that will result in a better productivity as far as the particular organization is concerned. So the focus improvement is related with the Kaizen, that is continuous improvement in the working environment, so that it will result in achieving a higher productivity as far as the organization is concerned. The third pillar is about the planned maintenance. That means studying the failure rates, looking at the historical downtime data, and maybe based on that, we can schedule the maintenance. So the maintenance has to be planned based on the historical data, based on the failure rate. It should not that when the maintenance department is having a time, they should plan for the maintenance. Okay. So depending on the failure rate, depending on the historical downtime, and based on the analysis of that particular failures, of that particular downtime, the maintenance has to be scheduled. Okay. Because it should not happen that the maintenance is being planned based on the availability of the maintenance people, but it should be based on the failure rates. It should be based on the downtime of the machines. And so the thing is that whenever the maintenance has to be scheduled, the maintenance to be scheduled around the time when the equipment is idle or producing at low capacity. That means if there is not much demand, and if the production rates are low, in that particular case, even the maintenance can be planned. But then you have to look at that there has to be rare interruptions during the production. Okay. And whatever the proactive approach that we have identified as a part of the autonomous maintenance, that means if the machine is being properly cleaned, if every day if it is cleaned, lubricated, or inspected, that will reduce in the unplanned downtime. Because if there are certain minor faults which are occurred by the operator or during the autonomous maintenance, if those are rectified at its early stage, then it will result in minimizing the major breakdowns which may occur in future. And maybe based on that, we can reduce the unplanned downtime, and we can plan for the maintenance as a part of the planned maintenance. So that will not have much impact on the production. So whatever the conflicting situation that we see in the maintenance and production, that can be minimized. The fourth pillar, it says about the quality maintenance, and the focus is on the errors, design error detection and prevention into the production process. So whatever the equipment is being designed, so this is related with the maintainability, because if the design of the machine is such that, for example, if a small fault it occurs, but it takes more time to dismantle the machine. Okay. So the concept that is called the design for maintenance, DFM. So machine has to be designed from the point of view of the maintenance function also, because if it is taking too much of time for dismantling, and if it is taking too much of time for again the assembling, so that will result in more downtime. Okay. So whenever we are looking at the quality maintenance, we can look at what are the working, the design errors are there, and whatever the faults that are occurring. So we will try to prevent those faults, and based on that, we can have a root cause analysis, and specifically we say the YY analysis. Okay. So whatever the fault that has occurred, we can go into the depth of it to identify the root cause, maybe based on the 5 why, which is called the YY analysis, so that we can ask the 5 questions in terms of why the fault has occurred. Based on the answer to that, why that fault has occurred, based on that, we can drill it down so that we can reach to the root cause of that particular fault. And maybe based on that, we can eliminate the recurring sources of those particular defects. So that is a part of the quality maintenance that we have to look at as a part of the TPM approach. And then the early equipment management, that means whatever the practical knowledge that you have obtained and whatever the understanding is being done based on the maintenance and based on the operation, we can utilize that in terms of the design also. Okay, so whatever I have mentioned earlier, that is design for maintenance, so that can be incorporated, so that based on the experience, based on the knowledge, we can look at how we can improve the design so that it will result in design for quality, it will result in design for maintenance also. So that's why it is called the total productive maintenance, because all the efforts that goes related to the production equipment, all those who are involved, they should be involved in that particular equipment, the particular machine, so that we can improve the performance of the machine. That will result in improving the productivity. The next pillar is the training and education. So of course, all the operators, managers, maintenance personnel who are involved, they should be trained to improve their skills so that they can proactively maintain the equipment and they can look at what can be the emerging problems. So the idea here is that maintenance should not be considered as a role of the maintenance department only, but then it should consider the involvement of all those. And when we are looking at the maintenance, we just not consider that whatever the fault has occurred, we have to rectify that fault or we have to prevent that fault. But based on that particular knowledge that is being gained, we can look at how we can improve the design of the particular machine. And of course, whatever the corrective actions that have been taken or whatever the changes that are being suggested, they should not have an effect in terms of safety, health, and environment. So maintaining the safety, maintaining the health, maintaining the environment is also an important aspect of the maintenance function. So because all the people who are working, they would like to work in a safe environment. They would like to have a working environment which will not have any hazardous effect on their health. And at the same time, whatever the actions that are being taken, it should not affect the environment. So all those actions should be sustainable. So any solutions which are introduced as a part of the TPM process should always consider the safety, health, and the environment. So it should not have an effect in terms of affecting the safety. It should not have effect in terms of affecting the health or any environment. So you can see that the TPM, it looks at all the dimensions as far as the organization is concerned, and at the same time, it should look at the administration also, because we have seen that there are so many issues which are because of the issues which are related with the administration also. Because for example, if you have if any machine failure it occurs, but if you have any long administrative process to report that fault first to the maintenance department, if you have a very long administrative process which is involved, that means if it is involved in too much of paperwork or if it involves too much of authorization by the different managers, so that it will increase the downtime of the machine. So the TPM, it also looks into the administration and it tries to identify the avenues by which the wastages in the administration process, that means whatever the non-value adding activities which are on account of the administration, those can also be eliminated so that it will improve the performance and it will result in improving the productivity. Okay, so when we look at the total productive maintenance, the organizations, they are concerned with one performance measure that is called the overall equipment effectiveness, which is popular is OEE. So any TPM philosophy, it tries to basically look at how we can improve the overall equipment effectiveness, that is called the OEE. And the basic object of the total productive maintenance is to maximize the overall equipment effectiveness. So as a part of the TPM philosophy, there are 6 major losses which are considered. So these are the 6 major losses related to the equipment performance are concerned. It is related with the breakdowns. So breakdown is a part of the loss that will have an effect on the overall equipment effectiveness. The second is related with the setup and adjustment. So whatever setup and adjustment that needs to be done on the machine, that will result in the major loss to the performance of that particular equipment is concerned. Then the minor stoppages or small stoppages, maybe because of some process adjustment, maybe because of some other idleness, maybe because of the material is not available, whatever it is. So that will have an effect on the performance of the particular equipment. Maybe the reduced speed of that particular equipment. So the startup reject, and the production reject. So it may be the reject or the defects which are occurred during the startup, or it may be the rejections or the defects which are occurred based on the production. So all these are considered to be the 6 major losses as far as the operation of the equipment is concerned. And based on these 6 losses, the overall equipment effectiveness is being calculated. Okay,
Sir,
so if you look at
sir, last slide, please. Sir, here, what is the meaning of startup rejects? I think it is the standard procedure that we have to reject some startup parts before starting the regular production. Then is it for calculating OE?
Yes, because see, sometimes if the process are not proper, so that it is resulting in more rejections. Okay, for example, if process setting is not properly standardized, so in that case, if it is having a more rejections, so that has to be accounted for the startup rejections.
Okay, sir.
Okay,
but sir, it is our standard practice, sir, that I have to anyhow I have to reject some startup pieces.
But then if the process setting is standardized, okay, if the operator is being properly trained, so let's say you have even the setting, but if the operator is not trained, what will happen? In that case, your startup rejections will be more.
Okay, sir.
Okay, because it looks at the total aspect. Okay, so if you could have seen that one of the pillar is training and education. So even though if your machine is a good machine, you have a standard process, but then if the operator is not being trained properly, what will happen in that case? The startup rejection will be more in that case. Okay, so we have to look at all the minor aspects that may have an effect in terms of the loss to the particular industry. Because any equipment, when we are concerned, it is expected in terms of its availability, it is expected in terms of giving the performance as rated performance, and it should give the required quality. So from that point of view, whatever the startup rejects or whatever the startup rejections that occur, those are also accounted as a part of losses, and we have to take measures by which we can minimize these startup rejections. But then if you consider the startup rejection, how much is the startup rejection in your case, in your company?
So it is about
so maybe in that particular
sir.
machine?
About 4 to 6% in aluminum die casting.
4 to 6%. Okay. But then we should have some targets by which we can.
But we have also many a small stoppage like metal pouring and little adjustment. That's why it is also increasing.
So the idea is that we have to improve the process, improve the system, because one of the pillars you have seen is that improvements, Kaizen. Okay, so you should always look for continuous improvement. And that's why you have to consider it as a loss and you have to take measures, you have to look at continuous improvement by which you can improve that.
Yes, sir, we can improve, but cannot eliminate, sir.
Of course, of course. So OEE will never be 100%. Okay, you cannot have an OEE of 1, but then you have to make it so that you can reach as higher as possible. So related with these 6 losses, there are 3 measures: the availability, the performance, and the quality. So based on these 6 measures, we have these 3 elements of the OEE, that is availability, performance, and the quality. So whatever the breakdown, setup, and adjustments.
Sirji, sir, do we consider the changeover time in calculation of OEE? Planned changeover?
We'll come to that.
Okay.
Okay. So if you consider the total planned operating time for the machine, in that case, you will have certain planned shutdown or the planned maintenance. So that if we remove it, then based on that, you will have a planned production time. Okay. And from the planned production time, you may have certain breakdowns, setup, adjustment. So that will result in an actual production time. Based on the actual production time, there will be certain small stoppages or maybe some kind of there will be the events that may occur based on which it will reduce the speed of the production. For example, let's say if any material is not available, so for some time the machine will stop. So that will reduce the production speed. So that will form the net production time. And based on that, we have a valuable production time wherein whatever the rejections that have been occurred, those rejections, if we eliminate, that will become the value added product which we can deliver it to the customer. So as far as any equipment is concerned, we identify these 6 losses, and based on that, we have the 3 parameters, that is availability, the performance, and the quality. And this OEE will be the multiplication of all these 3 factors. Okay. So the 6 big losses we have considered. The first set of loss is related with breakdown and setup and adjustment. So that will result in the downtime losses, and the parameter which will be related with the downtime losses will be the availability. That means how much time the machine is available for carrying out the production. Then the next 2 losses, that is idle and minor stoppages that will occur, and maybe some reason by which the speed of the machine is reduced, maybe on account of non-availability of the material or maybe account of some other reason. So that is related with reducing the speed, and whatever the speed losses will be involved, that will result in the performance of the machine. And based on the rejection, there we will have the quality losses, and that will result in the quality. Because any manufacturing equipment, we are utilizing it for carrying out the production. The first objective is that the manufacturing equipment should be continuously available. Okay, because we are not, as a part of the production process, we will always expect that the manufacturing equipment will be continuously available. So we are ensuring that whenever the equipment is there, it should be available. Okay, but because of the breakdown, setup, and all this, it is not feasible to have continuously available. But if we are looking at the extracting the outcome or output of that particular equipment, we will expect that the availability of the equipment should be very high. Secondly, the performance. Okay, now whatever the equipment that is designed and manufactured, that equipment is required or it will have certain rated performance. And our job or our objective when we are using that equipment is that we should achieve as close as possible to the rated performance of that particular equipment. So, but then in real life, there are some idleness, some minor stoppages, or some reduction in the speed by which we are not able to get the performance. So, the second aspect of the OEE that is related with the performance, we'll try to capture this so that we can reduce the speed losses so that we can improve the performance to as close as possible to the rated performance of that particular equipment.
So
Now,
setup and startup losses are both the same, no, sir, or different?
Which one?
Setup and startup.
So the startup are the rejections. Huh? This is related with the time loss.
Sir.
Okay. So whatever the setup and adjustment that needs to be done, that is a part of time loss, because ideally it is expected that if we look at the operating time of the machine, okay, we are expecting this much of the operating time. This is ideal. So whatever is the operating time, it should give the rated performance and it should give the required quality of that particular product. Okay, so this is what is the ideal requirement. But in real life, you will have certain losses. So these losses, they are considered to be the 6 big losses, which will have an effect on the performance of the equipment. Okay, and based on that, you will have the performance which is captured in terms of the overall equipment effectiveness.
Sir, sir, in 5th point, defect and rework is written. If the product is manufactured okay on a machine, and after in the next process it get defected, then it will be considered as machine's performance or not? Because here it is rework, and if the casting is reworked after in next process, then it will be considered in OE or not, sir?
See, as far as the equipment performance is concerned, the equipment is expected to give the quality at its first attempt. Okay, because if you can see that if your rework is more, that will result in reducing the productivity, because you will incur the cost on reworking of that particular pieces.
Sir, but machine is producing okay, sir. In the next process, it is getting defected. At the machine stage, when the casting was produced, it was okay, and in next process in fettling or heat treatment, it get bend, and and we do rework to eliminate the bend. Will this is this calculated? It will be calculated on OE or not, sir?
This is related with the individual equipment. Okay, so as far as that particular stage is concerned, if it is resulting in the meeting the quality requirement at that particular stage is concerned, it will not be included as a part of the defect. Okay, because we are doing it for the particular equipment. So whatever particular casting machine that you are considering, if it is not resulting in the particular, we can say, but provided that you should have an inspection which will we can say certify it that it is meeting the specification.
Sir, how rework can rework will considered in OE?
See, whatever the equipment that is operating, okay, what will be expected when you are purchasing any equipment, let's say machine you have purchased, what you will expect out of that? It should produce the quality of the product, which will be, or the product can be delivered to the customer. Okay. So if it is not producing, that means it is not effective. So that we are trying to capture it here, so that we can have some kind of an improvement in the system, improvement in the process, or maybe improvement in the machine that will result in improving the performance of that particular machine. Okay. And
sir,
that is what is the basis of the total productive maintenance. So it should not just looking at the maintenance aspect, it is looking at the overall involvement of the people that will result in improving the systems. Okay.
Okay, sir.
So basically there are three losses. One is related with the availability, the other one is related with the performance, that is the speed, and third is related with the quality. So in broader sense, you can say whenever we are looking at the equipment, it should be available most of the time. It should give its rated performance. Okay. And whatever rated performance that you are using, because whatever the time that is available, it should give the rated performance during that available time, and whatever the performance that we are doing, it should meet the specification. Otherwise, if you are getting these two, the machine is available, it is giving the rated performance. If there are more rejections, what will happen? It will result in reducing the productivity, isn't it? So to achieve the required productivity, we should have all these three measures, and that these three measures, they are captured in one performance measure that we call it as an OE. So the rejection may be during startup, the rejection may be at some intermediate state even. Okay, because even though it has occurred at the intermediate stage, but then at some point of time, if that particular machine is accountable for that defect, it has to be accounted as a part of the quality loss as far as that equipment is concerned. And you have to take measures so that the quality can be improved, the rejection rate or the defect rate can be, or the rework rate can also be minimized. Okay, so these are the ways by which we can measure these three major performance parameters of the OEE: the availability, then the performance, and the quality. Okay. Maybe in literature or wherever you will explore, you will find different formulas. Ultimately, it results in the three, that is availability, performance, and quality. And the availability is nothing but whatever is the planned production time and whatever is the downtime. So that means uptime divided by the planned production time will form the availability. Then whatever is the actual output that you have obtained based on against the planned one. Okay, so whatever is the rated performance of that equipment, against that whatever you are getting the actual performance, that will be captured in terms of the performance parameter, and the quality will be captured in terms of whatever is the total pieces that are produced, and out of those, how many pieces are acceptable. So that will form the quality aspect of that particular equipment is concerned. And based on the estimation of these three, we can capture it in terms of the parameter that we call it as an OE. So even if you can say that if availability is 0.9, the performance is 0.9, and even quality is 0.9, you can see that when you multiply all these, the OEE, it gets to around 0.7. So we can see that when we want to improve the OEE, it's not just the improvement in terms of the availability, it should not be in terms of performance, it should not be in terms of quality. We have to take the measures of the improvement in all these so that it will result in improvement of the overall equipment effectiveness. Okay, so that's why the TPM philosophy, it looks at involvement of all for improving the performance of the equipment. And for that, it starts with 5S as the foundation, and it builds on the 8 pillars, which involve the involvement of the all for improving the performance of the equipment. That should be in terms of the availability, the performance, as well as the quality of that particular equipment or the process, which will result in improving the overall equipment effectiveness. Okay, so we'll take one simple example, and based on that, we will see that how the OEE is being calculated. So let's say in a typical shift of 8 hours, that is 480 minutes is the total time that is available. In that, we have 2 short breaks, let's say 15 minutes. So 30 minutes are lost in that. There is a meals break or lunch break for 30 minutes. Okay. And let's say during the 8-hour shift, there is a downtime. Okay. That is for 47 minutes. And the rated output of that particular machine is 60 pieces per minute. So this is what is the ideal run rate that is called. So this is nothing but it's the rated performance of the machine. And based on the 8-hour shift operation, let's say these many number of pieces have been manufactured or produced by the machine, and out of these pieces 423 pieces were rejected. Okay, so that means the good pieces will be the difference of these two. So based on that, we can estimate the overall equipment effectiveness as far as the operation of this particular equipment in this particular operating environment is concerned. So the planned production time is, we are talking about the production time, okay, planned production time. So whatever is the shift length, 480 minutes, out of that 2 breaks of 15 minutes and 1 break of 30 minutes that we have to eliminate, and that means we have 420 minutes of the planned production that is available. Now out of that, operating time is how much? Whatever the downtime during which the machine is not available. So the operating time is now 373 minutes. So out of 420, 47 minutes are lost in the breakdown or the failure of that machine, and the downtime is 47. So 373 minutes are available. So that is what is the operating time. Now, how many good pieces that will be produced? So out of these total 19,271 pieces, 423 pieces were defective products. So those will be rejected, and based on that, 18,848 pieces, or the good pieces we can say, which are meeting the quality specification, those need to be considered. Now in terms of the 3 parameters, that is availability, performance and quality. So the availability will be, operating time is 373 against the planned production time of 420. So the availability of the machine is 0.88. If we look at the performance, so the total pieces that are produced out of the operating time, that is how much, and divided by the ideal run rate. So against the ideal run rate, that is the rated capacity, these are what the actual pieces that have been produced. Okay, so the first parameter, it will reduce the actual output divided by the rated output. So against the actual output, against the rated output, whatever the actual output, the ratio of these two will result in the performance. So if you look at this particular equipment, based on this total production that is obtained from that machine against the ideal run rate or the rated capacity, the performance is 0.86. And if you look at the quality, so whatever the total pieces that have been produced, out of those 18,848 pieces were good pieces. So that indicates the measure of the quality as far as that equipment is concerned. And based on these 3 estimates, we can see that the OEE is 0.7479. And based on this, now once we have obtained the OEE, then we have to look at that how we can improve the availability. So the role of maintenance will come in that. So improving the maintenance effectiveness, we can improve the availability. So if availability is improved, that will improve the OEE. Based on the output, because there will be certain losses which will result in reducing the speed of the machine. Okay, so those losses we have to account, and based on that, we will have the actual output against the rated output. So if we are improving the setup, because setup time or setup time is one of the major non-value adding time which is considered in the manufacturing scenario. And you can see that the industries, they try to achieve, or they look for the single minute exchange of dies. Okay, so that is related with minimizing the setup time. If your setup time is taking 3 hours or 4 hours, so this SMED principle, it says that you have to reduce it to that particular value. So setup and minor adjustment or any other reason because of which the performance is affected, those you can look at, and maybe based on that you can improve the performance. the third is related with the quality. So you can see that in this particular case, the rejection rate is 423 pieces out of total pieces of 92. So almost this is what is the quality performance. So based on that, you can take some measure by which the rejection rate can also be minimized so that the quality of the pieces, they can be improved. So if we improve the availability, if we improve the performance, or if we improve the quality, the overall equipment effectiveness can be improved. And based on that, we can see that the total productive maintenance approach, it looks at involvement of all the people who are concerned with the particular manufacturing operations. If all those are involved, we can improve the overall equipment effectiveness that will result in improving the overall performance of the particular organization is concerned.
Sir, last slide, sir, please.
This one or the earlier?
Earlier, sir. Sir, in operating time, you have minus 420 minus 270. Sir, 420 minus 470 operating time. It means you have minus the planned production time minus downtime.
See, you have the total time available for the shift. Okay. From that, you have the scheduled breaks. Okay. 30 minutes of the short breaks and 30 minutes for the lunch break. So that time will be eliminated. So that will become your planned production time. Okay. During which you will operate the equipment and you can carry out the production. Okay. Out of that, then the downtime of the equipment will be eliminated, and that will become the operating time during which the equipment will be operating.
Sir, next slide, sir, please, sir. Sir, either operating planned production availability. Okay, sir. Total piece. Oh, sir, how performance is calculated, sir? Total piece
It is the
divided by
actual
operating
output
time.
divided by the rated. So the equipment is designed to give certain rated output. Now in this case, the rated output is how much? 60 pieces per minute.
Sir, here performance is calculated on the available time of the machine, which the machine is running currently.
Yes, yes, yes.
Okay, sir. Take
So out of
understood, sir.
in this 373 operating time, you have produced 19,271 pieces. Okay, so this is what is the actual output per minute that you obtained. And what is the rated output? It is 60 pieces. So you have to take measures by which you can improve your output or performance so that you can reach as close as possible to the rated output.
Sir, considering the manufacturing industry in India, what is the average OE at which we are working currently?
See, the world-class standard, it says up to 85% we can, or 0.85 it can be. Okay, but then of course, even 0.75 or 0.78, even that's because you can see that to improve the OEE beyond we can say 80%, you should have a good availability, you should have good performance. So all these processes should be standardized. Then maintenance performance should be high so that it will result in high availability. So even 85% or 90% OE is quite good OE.
Okay, as per your knowledge, what is the maximum in India and which plant, if you have any?
No, because that
even
is
Maruti
that kind of
operates below
research.
90, sir.
Huh?
Even Maruti operates below 90.
That's what I'm saying, that to achieve that
Around
high
80 to
level,
80.
and even the OE of 1 even is not desirable.
Sir, if OE is 1, then there may be some mistake in the
Or even
calculation or in the system.
99%, 0.99 or
97 is
0.98.
max, sir. 97 is max.
Yes, that's what I'm saying, that even to that level, it is not possible. And it's not desirable even, because today's markets are so dynamic. Okay, there is so competition that exists, and even the life cycles are very short, isn't it? So from that point of view, 0.9 or 0.85 to 0.9 is a good or reasonable OE. Because in today's market, if you see, the life cycles are very short. So if you produce more, if you keep it as an inventory, if you increase the inventory in that particular case, so you have to look at the demand, you have to look at the other aspects also.
Sir, will the changeover time considered as the downtime, which is planned changeover?
Change is always planned, why?
Changeover.
No, some
changeover where?
Die change.
So
that is planned.
So that's a part of setup. So that's a part of setup. So when we say OE, whenever your equipment is operating, whenever it's running, so we have to find out the running state of the equipment. That running state should result in the rated output, and that rated output should meet the quality specification. This is what is the requirement in terms of the OE. So these are the three major, we can say, requirements as far as the output of that particular equipment is concerned, and that we have to capture in terms of the OE.
This calculation is only for a particular, only one single equipment, or we can do it for complete assembly line, which includes a lot of equipments. This
we have to do it for the equipment level, but then either it may be averaged out at the entire line, or you may have some kind of the weighted value or some weights which are being given to the individual OEs. Okay, so depending on the importance, the relative importance that you expect for the particular equipment, you may consider certain weight, and maybe based on that you can consider, if you want to consider the overall OE, so it may become a part of the weighted OEs, and based on that you may come up with the overall OE for that particular line.
So similar to reliability in series. So if one OE of a particular equipment get reduced, there is a chance for, is there any chance for the complete OE to get dropped down?
No, you cannot multiply it like that. It's not like the series system that we analyze. Okay, either you may consider the relative importance of the individual machine, and based on the weighted average, you may consider the overall OE, or even you may take the average of that. Okay, so this is about the OE estimation.
So what is the full form of OE?
Overall equipment effectiveness.
Equipment efficiency.
Effectiveness.
Effectiveness. Okay, right.
Can we have 10 minutes?
Okay.
I just wanted to discuss the purchasing this ABC analysis related with this which is involved in the inventory control systems, because as a part of spare part management and all that, this analysis will be useful. So we can have a quick overview of this inventory control system, and then we stop for the session. So can we continue?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Please.
Okay.
Today is the last session.
Yes. Okay, so okay, I will share this slide. So this is basically related with the purchasing function. So we have to, so I will share these slides. So there are different R's of related. That means whenever we are looking at purchasing the material, it should be in right quantity, it should be in the right quality, it should be at the right place, then it should be at right time, and then it should be at right price. So these are initially considered to be the 5 basic R's of the purchasing process. But apart from that, there are few more that are being added. That means it should have a proper contract, that is right contract, then right transportation, then the right attitude, right place of the delivery, right sources. So all these are considered to be the important parameters of the purchasing process. So based on the material that is received, we have to utilize the control system for the inventory. So whatever material that we are keeping as a part of the inventory, so we have to look at that, how we can have a control on these particular items, because each item will have a different usage value. Each item will have a different criticality. And based on that item, we should be selective in terms of giving the importance, because in any, let's say in any organization, whether it's a raw material that is being in the industry, or if it is any kind of a spare that is existing in any maintenance department. So we cannot have equal control on all, because each item will have a different the value in terms of its cost, or in terms of its we can say criticality. For example, we have washers, we have nuts, we have nut bolts, and we have the other high items which are having a very high value. So we should be selective from that particular point of view. So there are certain techniques which are considered to be the selective inventory control system, like ABC analysis or the VD analysis. So ABC analysis, it looks at the classification of the item based on its usage value. The another classification that is called the VD analysis, which looks at the items from the criticality point of view, because even though the item is a small, but it may result in sometimes very critical. For example, somebody pointed out about the die casting machines. So in those die casting machine, whatever the seals that are involved, so even though the price of that seal may be very, very low, but if it results in decreasing the pressure, which will have a very high consequence. Okay, so from that point of view, the criticality may be very high. So we can have the classification in terms of the VD analysis, that is vital, essential, and desirable, or in terms of the demand of that particular item, which may be in terms of XYZ classification, or in terms of how the items are being consumed, that is fast moving, slow moving, and normal moving. So depending on the consumption of the item. So in any organization, whenever we are carrying the inventory, whatever items which are being purchased or which are being existing, we should have some kind of a selective control on the items which are being kept in the inventory. So we look at the ABC and VD analysis, which are quite popular. So as we have already discussed that, the ABC analysis, it works on the Pareto's law, and this Pareto, who is an Italian economist, who gave his theory that it classifies the vital few from the trivial many. So he observed that 80% of the wealth is occupied by 20% of the community or the people. Okay, so this Pareto law is 80-20 principle. This is also called the 80-20 principle. And the Pareto law, we can apply it to inventories also, or as somebody pointed out, they observed that in case of the machine failure, 80% of the failures, they are contributed by 20% of the components. Okay, or even if we identify the breakdowns, so you will observe that 80% of the breakdowns will be contributed to 20% of the failures. Okay, so in that particular sense, the Pareto law is applicable to many situations. And if we apply the Pareto law to the inventory, and based on that, we can classify the items as A class item, B class item, and C class item. So we can see that there are 10 to 20% of the item which account for 80% of the annual usage value. Okay, so whatever the annual usage value, if we consider for all the items, we will see that the 10 to 20% of the items will account for 80% of the usage value, and those are classified as A value. So these are the high value items. Then there will be 20 to 30% item which will account for the remaining 15% of the annual usage value, and there will be almost 50% of the items which will account for 5%. So whatever the items like nuts, bolts, washer, which are required in a very large quantity, their value or the price is low, but they will account for only 5%. So of course, these figures may vary, but on a broader sense, we can see that there will be some low component which will account for the high usage. There will be some moderate component which will be account for some moderate usage value, and there will be a high number of items or high proportion of the items which will account for a very low usage of the entire operation. So in that particular way, we can classify the items as A class item, B class item, or C class item. So A class item should be given high priority. That means a tight control, including accurate records, regular and frequent view. So for example, in any industry, there will be certain spares which will be having a very high value. So those items, they can be classified as A class items. There will be certain items which have a medium priority, and we can have a normal control on those. And there will be C class item which we can give the lowest priority. For example, nuts, bolts, washers, or any other consumables, those can be classified as the C class item. So ABC classification, it classifies the item based on its usage value. Okay, so I will share this so that you can go through it, and we can see how we can do the ABC analysis. Okay, so let's look at this example, and based on that, how we can classify the items as a part of the ABC analysis. So let's say we have 10 items, and for each item, the price is mentioned here, and for each item, the annual demand is mentioned. Okay, so for example, C01, which is a parking thread, its price is 100 and its annual demand is 100. Okay, so based on this particular, we have to find the annual consumption. So the annual consumption is nothing but price multiplied by its annual demand. So if we are having an annual demand of 100 and the per unit price is 100, so the annual consumption value is 100 multiplied by 100, that will get to 10,000. So for each item, we have to come up with the annual consumption. So based on the annual consumption now, we have to find out, and we have to classify the item as A class, B class, and C class. So based on the annual consumption, you have to arrange those items in a descending order. And then based on its consumption and the item, we have to calculate its usage value. For example, the first component C08 is having its annual consumption of this value. And based on that, we have to find the cumulative of the annual usage value. So these are the cumulative annual usage values. And then for each item, we have to calculate the percentage as a cumulative value. For example, for this particular item, C08, its cumulative usage as a percentage of the annual value is 70%. Okay. Similarly, for second, it is 80.5%. For third, it is 90.5%. So for each item, we have to find the cumulative of the percentage as a part of the cumulative value. And based on that, how many equipments are as a part of this percentage. For example, it's just 10 items we have considered. So the first item, it will include 10%. The second item, it will 20%. Third, it will include 30%, so on and so forth. So based on this, we can classify the items as A class, B class, and C class item. For example, we can see that the first component has accounted almost for 70% of the total annual usage. Okay, so that item we can classify it as A class item. The next two items, if we look at, those have been contributed to the remaining 20%. So if you look at, so this accounts for 20%. So these two items, then we can classify it as B class item. And then the remaining component, if you look at, they have accounted for 8%. Okay. So these items, we can classify it as C-class item. So based on the annual usage, we can classify the items as A class, B class, or C class item. And then by plotting the percentage of the annual usage, so this is percentage of annual usage to the percent of the item, we can classify the item as A class, B class, and C class. So you can see here from the plot itself, this 10% of the item, it accounts for almost 70% of the usage value. The remaining 20% of the item, they account for the next 20%, and the remaining 70% of the items, they are accounting for the remaining 8%. So in this way, we can classify the items as A class, B class, or C class, and then accordingly we have to ensure the control over these items. For example, A class item will have to give a higher control, B class item we can give a moderate control, and C class item we can have a kind of low level of the control. So ABC classification, it classifies the items based on its annual usage value. But then if we just consider the classification based on the usage value only, in some situation, we can see that even though the usage value is low, but then the criticality may be high. For example, if any small seal or washer, if it is resulting in reducing the pressure, that will result in a major breakdown for the maintenance department, and which will involve too much of downtime loss, which will result in the productivity loss also. So even though the usage value is very small, but then the criticality is very high. So in industry, we should not always classify the items based on the usage value, that is ABC. We should also include the criticality of the component. Okay. So there will be few items which will be vital. That means non-availability of those items will entirely halt the system. There will be few items which will be essential. So those items will be essential, but then it will reduce the performance. Okay, it will not stop the system, but it will reduce the performance. Those items are classified as essential, and there will be certain items which will be desirable. So
why we are classifying, sir?
Why
we are classifying in ABC? What is the purpose?
Because in the inventory, you will be having so many components. Okay. So how will you execute the control on these items? For example, let's say you have some kind of component which is having a very high usage value. So you should know that which component are having A class, which component are having B class, or which component are having C class. Because see, if A class item which is having a very high price and its usage is high, you will not keep those items too much in the inventory. Otherwise, what will happen? You will invest a lot of capital in that particular A class item.
Yes, sir.
Okay. So you have to ensure the control. You should identify the alternate vendors for those particular components. So that if that component, if it is a kind of a maintenance spare, in that particular case, if that spare is not available with the one vendor, you can have an alternate vendor available for that. Otherwise, what will happen? It will increase the logistic delay time. Okay. So you should have what kind of control is required on all the items which are required for the machine. You should have certain classification. For example, you will not be bothered for the nuts, bolts, and washer. You can purchase it in bulk and you can keep it because there is very low usage value with these components. But the components which are having very high item, high usage value, those should be given a very tight control. You should continuously monitor it. Okay, so from that control point of view, you should classify the items in terms of ABC. But just classifying based on the usage value will not be sufficient. You should also look at the criticality, because it may happen that a very C class item, but it may have an impact on the functioning of the system. It may stop the functioning. For example, those who have who are working maybe in the die casting industry, so they can understand the importance of the seals which are used in that particular machine. So with any seal broken, it will reduce the pressure. Okay. So from that point of view, the usage value is low, but then the criticality is very high. So we should not look at just ABC analysis. We should combine it with the VD analysis, which is based on the criticality. Okay, so the vital items which are essential, with which the system will not start. For example, if you look at the engine assembly, the piston rings are vital items. So even though its usage value is low, but if the piston rings are worn out or if they are broken, it will not start the engine. Okay, so those items are vital items. Essential items are those which will not stop the system, but then they will reduce the performance. Okay, so those items are classified as E items. So for example, oil seals in engine, they will reduce the performance. Okay, so those are E items or the essential items. And there will be third category of the item, which are the desirable items. For example, in case of the engine assembly, if we look at the cover on the engine, but then it's a desirable item. It will not stop the system. It will not reduce its performance, but then it's a desirable item because that may cause accident. So in any spare part management or in any inventory system or in any items which are purchased, you should have a kind of control on all the items based on its usage value or based on its criticality. So as a practice, the single classification in terms of ABC or VD is not employed in terms of the combination of these two. Okay. For example, if we consider the classification in terms of ABC and in terms of the VD analysis, we can see that this particular cell, it will result in the combination of A and V, that is A class item which are vital. This will result in A class item which are essential. This will result in A class item which are desirable. Okay. So we should have a control in terms of these classification. Okay. So there will be a first classification which will include AV, AE, AD, BV and CV, because A class ABC. So even though it's a C class item, but if it is a vital, we should have a tight control on that, because even though the usage value is low, it will stop the system. Okay. So the classification should be in terms of these three categories. So AV, AE, AD, BV and CV. So this should be given a tight control. Then the second category is the second one, which is highlighted with a green color. Okay. So we can have a moderate control on that. And then the last, which is being highlighted in terms of the D, C and D combination. So we may have some kind of a low level of control on these particular items. Okay, so depending on that, we can have our inventory policy. For example, A class item and vital, we should have a regular stock with a constant control on that. Similarly, A class item with an essential criticality, we can have a medium stock, and maybe A class item with a desirable one. Either we may have a low stock, or even though if we don't have a stock, because if it is easily available in the market, it will not have a much impact. So based on this particular classification and combination, we can ensure the control. And in inventory theory, we call it as a service level, or we call it as a cycle service level. So these may be the service level requirement in terms of the classification of the items. So for example, A class and V vital item, we can have a 90% of the service level. And similarly, for other components, we can have a different service level. So this is a different analysis in terms of the service level expectation in terms of maintaining those items in inventory. And based on that, we may have a classification of the items, and depending on that, we can have a trade-off between how much inventory that needs to be carried out. But of course, when we are looking at storing these items as a part of the material, we should ensure the control in terms of its usage value or in terms of its criticality. And maybe based on that, we can decide that how much inventory that we should maintain. And for that, we have to achieve a proper trade-off. For example, the A class item, it says less inventory, but since the component is a V class item, we should have more inventory, because if that item is not available, it will stop the system. So we can have a proper trade-off between the policy decisions that how much inventory or how much material that should we keep. So from the maintenance point of view, the spare parts management, you can employ this classification, and based on that, you may come up with how much spares inventory that you will carry based on the classification of the items, either as ABC or VD. And of course, you will try to involve the combination of it, and based on that, you will ensure the required inventory for the spares that you will carry in the department. Okay, so we'll stop our discussion as far as this course is concerned at this point, and I will share all these things with you. And maybe based on that, if you have any doubt or anything you want to discuss, you can send a mail. You can send a mail to me, and of course, this journey will not stop at this point. Okay, we will have a continuous relationship, and maybe based on that, whatever things that you want to discuss or you want to share, we will have a regular contact with all of you. And now, as far as your quiz is concerned, we have done the 2 quizzes. So those who were absent in the quizzes or those who were not able to submit the quiz, okay, for those we will have one makeup quiz. That makeup quiz will be based on the entire syllabus, and we will conduct that quiz before your end exam is scheduled. So I think your end exam is scheduled on the next Sunday, that is on 13th.
No, sir, 20 March.
20th.
It is week
Is
after
it on
next.
20th?
It is week after next.
Okay. So, okay, fine. So before that, then we will have the makeup quiz for those who were not able to submit the quiz. And of course, I will share one sheet. Maybe those who have not submitted the quiz, they can share their names so that I will get to know who are giving the makeup quiz. Okay. So that is related with the quiz. I think one assignment you have already done it. I think today is the due date for that assignment.
Yes, sir.
Yes, sir.
Tomorrow.
Okay. So you will submit that assignment. One more assignment I will announce maybe tomorrow, which will be based on the scheduling and maintenance concept. So as a part of evaluation, you will have to submit these 2 assignments. Okay. And I think instructions about the assignment submissions are also clear, that you have to mention the contribution of the individual member. But if you are not mentioning anybody's name in that, you will mark a mail to that person, as well as you will mark a copy of it to me also. Okay. Okay, fine. So your end term will be based on the entire topics that we have discussed. And if any doubt you have related to it, you may post that doubt. I think somebody has sent a mail related to the scheduling. Maybe by tomorrow I will try to answer that particular query. So, okay, so that's it from my side. If anything you want to ask, you may.
So after this assignment submission, the correct answers or the assignment which is proper and all, you can give a feedback on that one. So that's correct, good assignment. Because
okay, I will try.
Yes, sir.
If any
score of the
major
quiz
comment is there. So see, practically it won't be difficult. It won't be possible to give the comment on each and every aspect of the solution, but overall major comments I will try to give.
Okay.
Yeah.
Sir, I have a question. Sir, I have a question. Am I audible, sir? Is this okay?
Yeah.
Sir, this the assignment naming, you told how to the file name, you give some specific
It's just
rule.
a simple term, the group number and the assignment number. Since there are 2 assignments,
Okay.
so the first value is the assignment, the group number.
Okay.
So for example, it is group 1, group 2, group 3, like that. So it is G01, let's say. And then you have 2 assignments. So assignment 1 and assignment 2.
We have group names.
So I will be able to recognize the files.
Okay. So that means G02 and C2. If it is C1, first assignment.
C1 and C2. like that.
So we have group names, sir. We will put group names there instead of group number.
No, the file name you will give as per this convention. Because when I will keeping these files in my folder, I will recognize the files with the group number. I think that is pretty simple, huh?
Yeah.
Just giving the group number and the assignment number.
Sir,
Okay. Is there anything?
Score of last quizzes perhaps not shared, sir.
No, it's already shared. Quiz 1.
Quiz 1 and 2 all. Both.
No, quiz 1 is already shared. I think others have got it.
Okay, sir.
See, as far as the faculty is concerned, we have just one button there, that release score. Okay, when we click it, it automatically goes.
Yes, sir.
Okay, so if any issue that arises on the part of the Google services, we don't have any control on that.
Yes, sir.
So it is as good as when you click the send button in your email, what happens at the later stage that you don't have also control. Okay, then. So we'll stop here today, and it was a nice interaction with all of you. And I think we will continue this journey, and maybe in future we'll be in contact, and maybe whatever you want to interact with me, we can continue our interaction. And I wish all the best for your exam as well as all your future endeavors. Okay.
Thank you, sir.
Okay, then. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you.